Hello, my name is Mahmood. As part of my PhD program, I've been asked to make an introduction to Generative Adversarial Network, shortly GAN. These four images were all generated by GANs. GAN also has application in medical field. What you are looking at on the left column is MRI images of the brain. In the middle one is the real CT scans. And the third column is the synthetic CTs generated by GANs. The last column is the differences between the real CT and the CTs generated by GANs. But to understand GAN, we have to look at game theory. In an adversarial game with two players competing against each other, such as chess, the first player tries to minimize the score of the game, and the second player tries to maximize the score. Hence the name min-max or max-min. Similarly, GAN also has two parts or players. First one is the generator and the second one is discriminator. The generator learns how to fool the discriminator by generating the plausible images. The discriminator learns how to differentiate between plausible or fake data from the real ones. In the left image, you can see the structure of a simple GAN. The generator makes sample data or fake images from a normal distribution noise. Discriminator looking at the real data and the fake data generated by generator try to distinguish the fake one from the real one. In the left image, you can see min-max tree taken from game theory. 8, 12, 1 and 2 are the samples, and the dark green is the minimizer and the lighter green is the maximizer. Minimizer select 1 out of all the samples because it's the minimum, and the maximizer select 3 from 1 and 3 because it's the maximizer. Similarly with GAN, in the right image, there are 4 samples in the bottom from which generator picks the best one. Because the generator wants to minimize the loss function, which means the differences between the generated images with the real images should be the minimum. Discriminator between the real image and the image generated with the generator picks the real image, because discriminator wants to maximize its ability to distinguish between fake and real data. As mentioned before, discriminator tries to maximize its loss function, while generator tries to minimize its loss function. On the top, the equation for min-max for a GAN is shown. In the equation in top, d of theta d of x is the discriminator output for the real data, d of x. G of theta d of phi is the generator output, which means fake data generated from the random noise distribution phi. Going back to min-max in game theory, discriminator here tries to maximize d of theta of d of x to 1, and the d of theta of d of g theta d of phi to 0. That means better discriminating the real data from the fake ones. While the generator tries to minimize d of theta of d of the g of theta of d of 5 to 1, which means better quality of fake data. But how to train GAN? The input to the generator is random distributed noise, from which generator tries to make as real as possible fake data with high quality. These images were sent to discriminator along with the real images. The job of the discriminator is to binary classify the fake images from the real images. That is as if a discriminator is like a coach to the generator. That way, discriminator teaches generator to make better counterfeit images. Here is a pseudocode of training GAN. For a number of iterations, as a hyperparameter for training iterations, do the following. Sample n times from the probability distribution of the noise phi. Sample n times from the real data images x. Update the discriminator by ascending the stochastic gradient on its loss function, and then update the generator by descending the stochastic gradient on its loss function, and repeat the iterations. To highlight some notes about GAN, as it was mentioned, GAN is a two-player structure, namely generator and discriminator. Both players are implemented with neural networks. Worst case input for one player is generated by the other player, which means discriminator always sees the best output from generator as real as possible fake data generated by generator, and tries to distinguish between these images to the real ones. At the same time, because discriminator is coaching the generator, forces the generator to make better images. That is done by discriminator penalizing the generator for producing bad images. GANs are trained in supervised manner, but there could be many correct answers to them. That is in contrast with the classical supervised learning, where there could be only one answer, or an answer which is the closest to the correct answer. The reason for many correct answers is that GAN is a density estimator, which means by providing the training data, generates new samples from the same distribution. GAN sample from a simple distribution and transfer it to the training data distribution. That is done by generator fooling the discriminator by generating good-looking data, while discriminator tries to catch the generator by binary classify them and distinguish fake images from the real one. With that, I thank you for your attention.